Okay, an astronaut is on the moon, drops an object from 1.5 meters high off the ground, and observes that it impacts the ground 1.36 seconds later. So there's the ball, it drops, it hits the ground. The initial velocity is 0. The time that it takes for this thing to hit is 1.36 seconds.
Your x in the y direction.
And the displacement in the y direction is 1.5. And they basically want to know what the acceleration is. So
Wouldn't that just be 9.8?
no, because you're on the moon.
Oh, okay.
You should get an answer that's close to like 1.67 or something like that. Okay, so you use the second one. This thing is 0. You just plug numbers in.
Do you know how to do like solve a quadratic in a calculator?
Mm-hmm.
How do you set that up?
Go like this. F2 for algebra.
I gotta get out the stats. Go home. F2 algebra.
Solve.
Solve.
And just type it in. 1.5 equals 0.5 times x times 1.36 squared.
You don't have to any.
And you just say solve for x. You put comma x.
Okay.
And then you're done.
1.6.
1.62 meters per second squared.
It says negative though.
Whatever. I mean, sure, down. If you say down is positive, you're good. A ball is thrown at a 30-degree angle above the horizon at a speed of 25 meters per second. So there's a ball. This is 25 meters per second. This problem is significantly more difficult than the other one.
And this one?
Yeah, yeah.
Well, you gotta get components, right?
Yeah. So 30 degrees. Oh, and it has some initial height.
Yeah.
Of
this problem was on the test.
1.5 meters. Okay. At a time of 3 seconds after the football was thrown, how far has the football traveled horizontally? It's actually not that bad. So, because a lot of this stuff is superfluous. But if you wanted to be like,
what does superfluous mean?
Like extra, like you just don't need it.
I guess all relevant.
Yeah, but like if I guess the thing that you should do is check to see if it hits the ground before 3 seconds.
Okay.
So if you're being like really good about it, this thing takes, some path that goes like this, right?
Mm-hmm.
So the displacement in the y direction is negative 1.5 meters. Right, like if you start here and you end up here,
going down, right?
Your displacement was down 1.5. Your acceleration in the y direction is 9.8 meters per second squared. The initial velocity in the y direction is equal to 25 times sine of 30, right? And
yes, you said that was in your y direction, right?
Say it again.
It's in your y direction, right?
This is in the y direction. And then the thing I guess what I would do is solve for time, and just this will tell you how much time it takes for it to hit the ground. And that way,
from this point, right?
Yeah, like if it starts at 1.5, there's like 3 seconds of airtime is actually kind of a lot, right?
Mm-hmm.
So I'm just going to figure out if it hits the ground before 3 seconds.
Okay.
Because then it changes the problem if it does, right? So the displacement in the y direction equals v naught t plus 1/2 at squared. So I get negative 1.5 is equal to 25 times sine of 30 is 12.5 times time minus 4.9. That's half of negative 9.8. Oh, this should be negative. My bad. My bad. Yeah. Everything else is good. T squared, right?
That's usually we set that up by going down to negative for this.
Yeah, but I set it so that like this way was positive.
Okay.
So then T, because you have a fancy calculator.
Yeah, you can plug that shit right in.
Yeah, so negative 1.5 equals 12.5 times x minus 4.9 times x squared. Solve for x. Obviously, the negative answer doesn't matter. Okay, so yeah, he pulled some bullshit. This thing hits the ground after 2.67 seconds. Right, so I guess.
What? So then, at a time of 3 seconds, wouldn't have been rolling at that point?
Right, so I guess, I mean, to solve the he probably didn't intend to do this. This is one of those things where a teacher makes up a problem and they don't realize that this thing hits the freaking ground first. But let me just double check, make sure everything. Yeah, 25 meters a second, 30 sine of 30 is a half, so that's 12 and a half.
Mm-hmm.
Yeah, all that's good. So I guess we're assuming that the ball just like sticks in the ground, right? Like playing in the mud or something. So that means the velocity in the x direction is equal to the displacement in the x direction over time. Because for projectiles, it's constant. Because there's nothing accelerating it.
Accelerating, right.
So you have 25 times cosine of 30. That's this component down here. That's cosine of 30 equals how far it went over how much time it was traveling like that, which is not 3 seconds. It's only 2.67 seconds.
But you have to use that 2.6 seconds?
Yeah, you have to use that.
Okay.
Because for that other third of a second, it's not a projectile. So I can only apply this when it's a projectile.
Gotcha.
So the displacement in the x direction is 25 times. And I don't care what that says. This is correct. If it gives you
I know, I'm sure it's gonna. Well, that's why I want to see what it says. This guy's a dumbass.
So this is 57.81 meters. That's the answer. I don't care what anybody says. Nope.
Yeah, he uses the 3 seconds.
He's wrong.
Yeah,
It hits the ground. Yeah.
Okay.
Maybe if you're throwing it off a cliff.
Okay.
Okay. Or I guess if the ground is like, no friction at all, and when it collides with the ground, there's no energy lost to heat, then maybe. But
what do you want, dude? You just want love, don't you?
So, yeah, whatever. My answer's right. His is wrong. A person can't carry very much weight, so they try to push a large 100-kilogram box that's initially at rest with a horizontal force of 250 newtons. The coefficients of static and kinetic friction between the box are 0.5 and 0.25. Will the person be able to push the box? All right. So there's this box. It has a weight force on it. It has a normal force on it. And we're going to analyze it before... I'm going to analyze it before it gets going, because that's what determines if you can push it or not. So it looks something like that, right? And I'm going to say things that go like this are positive. So if I sum forces in the y direction, I get normal force minus the weight force times the acceleration in the y direction, which is 0, because this thing's only moving horizontally. So that means that the normal force is equal to the weight force, right? And because the force of static friction is equal to the coefficient of static friction times the normal force, that means this thing, and I figured out that the normal force is equal to the weight force. That means that this is like that.
Oh, yeah.
And the coefficient of static friction is 0.5, so I get a 0.5 here. The mass of the box is 100 kilograms, right? Yeah, 100 kilograms, and its weight is 9 point, whatever. Can you read that? 9.8.
I get it.
Close enough. So when you do that, I don't know, I think you get 490, but I could be wrong. 0.5 times 100 times 9.8. Yeah, 490. So 490 newtons is the force due to static friction. And because so if you sum the forces in the x direction, that's the pushing force minus the friction force. And remember, this friction force is like up to 490. It's anywhere between 0 and 490.
Yeah.
And so
that's like its max.
this is a maximum for it. So because the pushing force is only 250 newtons, that's not like the friction force. This friction force outdoes the pushing force. So the pushing force isn't enough to overcome the thing. So
no, hang on.
So I hate you, little shit. God damn it, Jack, you little fucker. So no,
Oh my god.
cannot push.
Just sheds hair.
I gotta brush him today. All right.